Okay, guys, had a little technical difficulties with the last video I shot, so I apologize, but you're not going to get to see me work through these, but I will walk you through exactly what I did, and hopefully this helps. Again, what we're looking at is we're continuing our look here in 5.2. We've talked a little bit about graphing logarithmic functions, and now what we're looking at is how do we graph these things, all right? So the first thing I did when I was talking to myself, thinking I was shooting a video, and when I really wasn't, that was awesome, was looking at the graph first off of an exponential. So an exponential looks something like this: y equals b to the x power. We know that always goes through 0, 1, always has really small growth here at the left, and then explodes to the right. So we talk about, they talk about this virus growing exponentially. That's what they're afraid of, even though we see really, really small growth at the beginning. Eventually, it's just going to, explode on us. That's why you hear about flattening the curve and things along that line. But a logarithmic function, which would look something like this: y equals the log base b of x instead of y equals b to the x power. Since they are inverses of each other, okay, this one undoes whatever that one does. It means these graphs should be symmetric about the line y equals x. All right, so if I've got the line y equals x and I flip this over, the graph of a logarithmic function looks something like this. All right, and we're going to look at a little bit more detail later about how to graph these. But just some comparisons between an exponential function and a logarithmic function. Again, an exponential function looks like y equals b to the x power. It has a y-intercept of 0, 1. The domain of this thing, the things I can put in for x here, are all real numbers. All right. The range of this thing is anything bigger than 0. You can see here from my exponential, remember we talked about this, it gets really, really close to 0, but never actually touches it. All right. So, the outputs for this are really any positive number, but it'll never reach 0. And then, so kind of hand in hand with that, we talked about exponential functions having a horizontal asymptote at the x-axis. So logarithmic functions, again, they are inverses of all these. So if I talk about a logarithmic function, it looks like this: y equals log base b of x. If this thing if an exponential had a y-intercept at 0, 1, means this thing has an x-intercept at 1, 0. Again, when we talk about inverses, we're basically talking about taking all the x's and y's and just reversing them. All right. So you see here the domain of an exponential is all reals. If I switch that over to a logarithmic, it means the range for a logarithmic function is all reals. If the range, what I can get for y for an exponential function, is any positive number, that means the domain for a logarithmic function is any real number. And if an exponential function has a horizontal asymptote and it's the x-axis, a logarithmic function is going to have a vertical asymptote, and it's going to be the y-axis. So again, these are inverses of each other. We're just basically taking x and y and switching those around. And we're going to see how this applies here in just a little bit when we get to graphing these things. But one of the things you're going to be asked to do on your homework is to find the domain of, again, not just a basic logarithmic function, but a shifted logarithmic function. A logarithmic function, easy for me to say, a logarithmic function that's been moved, all right, or changed slightly. And here's what we need to catch: that you can only take the log of a positive number. We saw that a little bit on yesterday's homework. You can't do the log of a negative number. So if I have the log, and again, that's just base b, it means it doesn't matter what the base is. This is always going to be true. If I take the log of x plus 2, whatever x plus 2 is has to be positive. So I write an inequality that says that x plus 2 has to be greater than 0. And now I solve this for x. All right, take away 2 on both sides. The domain of this function is all x's bigger than negative 2. Okay, and in a similar way, if I want to know the domain of this function, well, whatever 3 minus 5x is has to be bigger than 0, has to be greater than 0, has to be positive. And now I'm just going to solve this. I'm going to solve this two-step inequality. I'm going to do addition and subtraction first. I'm going to take away 3 on both sides, and then I'm going to divide by negative 5. And then you remember, when we divide an inequality by a negative number, that inequality sign flips over. So my domain for this logarithmic function is x is less than 3/5. So to find the domain of a logarithmic function, you simply take whatever you're taking the log of, whatever expression you're taking the log of, and set it greater than 0, and then solve that inequality. Now, if we look at graphing these, all right, so again, let's start here. So if I'm graphing, if I want to graph this logarithmic function, y equals 3, or I'm sorry, y equals log base 3 of x. The first thing I do, the easiest thing I found to do is to write that as an exponential, all right? And again, we talked about that a little bit with yesterday's homework. Again, these are two equivalent equations. They just look a little different. So to say that y equals log base 3 of x is to say that, really what this is saying is 3 to the y power equals x. And then what I've done here is make a little input-output table. Now, normally we're putting things in for x and seeing what y is. But in this case, y is actually kind of like your independent variable, and x depends on y. So what I did is I put in values for y. I put in 0 for y. If I put in 0 for y, 3 to the 0 power, anything to the 0 power equals 1. So if y is 0, x is 1. Then I put in 1 for y, 3 to the first power, x would be 3. And then I put in 2 for y, 3 to the second power equals 9. So the point 9 comma 2 is in my input-output table. And then I plotted these points. And again, when you're plotting these points, all right, this is still the x-axis, and this is still the y-axis. You're going to plot these points like normal, all right? So 1 comma 0 goes right there. 3 comma 1 is right there, and 9 comma 2 is right here. And then again, so we have the basic shape of a logarithmic function. You can see that. Again, that's kind of what we were expecting here from what we talked about on the front, all right? So that, there's the basic form, and I just kind of connect those with a nice smooth curve, knowing that my y-axis is an asymptote. I don't want to go across that. And so what I did then to do, y equals log base 3 of x plus 3, since it's really the same thing, it's still log base 3, but now I've got this plus 3 inside the function. And we talked about before that inside the function moves this graph left and right, and it actually does the opposite of what you would think. So when I see plus 3, it's going to take this entire graph, and shift it left 3, all right? So what I did is I took each of these points and shifted them left 3. So 1 comma 0, if I move that left 3 units, that became negative 2 comma 0. 3 comma 1, if I move that left 3 units, that became 0 comma 1. And 9 comma 2, if I shifted that left 3 units, that became 6 comma 2. And my asymptote, all right, which was the y-axis, if that gets shifted left 3, that actually becomes this line, x equals negative 3 right here. And then I connect those points with a nice smooth curve. And then hopefully you can see that this graph is simply this graph shifted left 3 units. We can also take these things and we can shift them up, all right? Again, this is outside the function. Again, you notice it's log base 3, so I'm really doing the same thing. If this would have been a log base 4 or log base 5, I would have had to go back and start from scratch and get 4 to the y power or 5 to the y power. But this is still just log base 3, so it's still that same graph we started with. But now outside the function shifts it up or down. But it's exactly what we think it might do. All right, so when I see plus 1, it shifts it up 1. So all I did here, now again, this is still the same table from our original function, from y equals log base 3 of x. This is not an input-output table for this one. This is my original, my parent input-output table. I just use those as a reference. So now 1, 0 is in my parent. I want to shift that up 1. That became 1 comma 1. 3 comma 1 was in my parent function, so I want to shift that up 1. That became 3 comma 2. And 9 comma 2 shifted up 1 became 9 comma 3. And then if I have an asymptote, if I shift that asymptote up or down, it doesn't change. All right, so my asymptote is still the y-axis, and so there's my graph there. And then finally, we can get all sorts of crazy and shift this thing a couple different ways. So here I've got the negative sign in front. That reflects it over the x-axis. I've got the minus 3. It's inside the function. So that's going to shift it left or right, and it's going to go opposite of what we think. So it's actually going to shift it right 3. And again, I just rewrote my table for my parent function, just have that as a reference point. And now again, I start inside the parentheses. So I'm going to do this shift first, then I'm going to do this one. So 1 comma 0, shifted right 3 became 4 comma 0. And if I reflect that over the x-axis, it actually doesn't move because it's right on my x-axis. So that point doesn't move as far as that shift goes. 3 comma 1, shifted right 3 became 6 comma 1. But then if I reflect it over the x-axis, that became 6 negative 1. And then finally 9 comma 2, if I shift it right 3, that became 12 comma 2. But then if I reflect it over the x-axis, that became 12 negative 2. And my asymptote here, the y-axis, it's not going to get affected by this, all right? Because if I take a vertical line and reflect it, it's still the same vertical line. So it's only going to get affected by this. So it gets shifted right 3 units. So my asymptote is right there at the line x equals 3. And then I connect them with a nice smooth curve. Okay. All right. So again, just a couple things that I need you to pick up for today. How to find the domain of a logarithmic function, and it's basically whatever you take the log of, set it greater than 0, and solve that inequality. And then how do you graph logarithmics? Graph the basics by changing it to an exponential and making an input-output table. And then what kind of shifts are we doing to this thing? Are we shifting it left? Are we shifting it up? Are we reflecting it? What are we doing to these things? All right. So here's your homework over this section. This is, again, 5-2, spending a second day on this. So take a look at those problems. Make sure you share those with me through Flipgrid. You guys are doing a real nice job of that. But please, 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 if there's some of these you don't get or don't understand, shoot me an email, send me a message to remind. I'll be more than happy to work through some of these with you guys. All right. Hope that helps. Look forward to hearing from you guys. Take care.